Yeah, welcome to all of you, and thank you for coming to the second lecture of this fall's lecture series, God and Computers, Minds, Machines, and Metaphysics. To start the whole thing, we also have a website. Several people asked for that. I just wrote down the address. So if you want to check the website, if you want to see future speakers, the abstracts, and so on, even though I have to warn you, the abstracts usually come only 1 week before the actual talk. The address is http://www.mit.edu/events/god-and-computer.html. Last week I forgot, but this week I definitely want to at first start this thing by thanking all the organizations which support this series, which is the MIT Electrical Engineering and Computer Science Department, the Artificial Intelligence Lab, the Boston Theological Institute, the Sir John Templeton Foundation, the Center for the Studies of Values in Public Life of Harvard Divinity School, and the Faith and Science Exchange in Boston. I thank all these organizations for very generous help, not only financial, but also in terms of organization and stuff. And I also want to mention that the discussion group we have organized at Harvard, which is run by Professor Harvey Cox and me, actually does not take place next Monday. We forgot, it's Columbus Day. So unfortunately, this thing will not happen. So we will meet the first time on the 27th of October outside our brochure. So if you want to have the dates for all 3 meetings, look in this brochure. But the changes, unfortunately, I'm sorry to say that, but the meeting is not at 1, but at 12 o'clock in the refectory in the small dining room at Harvard Divinity School, 45 Francis Avenue. You might find it on any Harvard map, I guess. And it's open for the public, so anyone can come. And for students, it's for non-credit. It's just for the interest of this thing. And now it is my absolute pleasure to introduce Marc Hauser, the second speaker of this series. Marc is currently Associate Professor in the Departments of Anthropology, Psychology, and the program in Neuroscience at the Harvard University. He is also a member of 2 interdisciplinary faculties, the Speech and Hearing Science program of MGH, Harvard and MIT, and the Mind, Brain, and Behavior program at Harvard. He has worked with several various monkeys group on a variety of different problems like aging, parent-offspring and gender relationships, sexual behaviors, facial expressions, perception, and repeatedly on language and communication. This last part of Marc's research has led to the 1996 MIT Press book, The Evolution of Communication. And while reviewers all say that this book has a clear potential to become an absolute classic in the field, I like it because it's absolutely fun to read. And so in that sense, I can highly recommend that book for anyone who is interested in this sort of thing. I first met Marc when we were in our robotics group questioning or dealing with questions of self-awareness. And we had this big problem to understand what that is. At the same time, I lost a bet, and so I was forced to dye my hair purple. And so my boss, Rodney Brooks, looked at me and said, well, you know what? There is this guy at Harvard who dyes monkeys' hair blue, and he found out that they have self-awareness that way. And this is how I met Marc. So Marc, I'm very happy that you're here to share your ideas on perception of self and mortality.
I suppose the title, like the one I gave, I should be a little bit humble. So I'll start out by telling you a story about my daughter, who has always sort of taught me some interesting things. And when she was about 4, I walked into her room, and she was sitting on the floor with a book between her legs. And I noticed the book was upside down. And I said to her, Alexandra, the book's upside down. And she sort of looked at me and looked at the book and said, yeah, but the world's upside down. And I thought, well, I guess it is just a matter of perspective. And what I want to do with you today is sort of share a perspective that I sort of hold dear to my heart. And that's a perspective that Charles Darwin brought to us. I don't know if we need the lights down a little bit, maybe. Can we have the lights down? Yeah, that's probably good. in one sense, the topic for this series, God and Computers, I think Darwin has some interesting things to say. The Darwinian revolution has often been put in opposition to religion, but as many of you know, Darwin himself was quite a religious man. And of course, what Darwin sort of forced us to sort of take seriously is the idea that there is continuity between humans and non-humans. And Darwin really could be considered one of the first psychologists, because Darwin took the idea very seriously that not only do we share continuity in terms of what we look like in terms of our morphology, but also in terms of how we felt about the world and how we thought about the world. Now, we have this extraordinary fascination with our uniqueness. And in fact, we could almost say it's an obsession with our uniqueness, to the point where we have movies trying to put ourselves in opposition to the animals or having the animals rule us. And we think this is kind of cute, but of course we know it's not possible. But this obsession, I think, blurs what are really the important questions about thinking about our evolution. That in one sense, all animals come into the world with special features, things that make them special and unique. So the claim that we're unique really just begs the question, unique in what way? And what I hope to reveal to you today is some of the ways in which we are special, but also some of the ways in which we share common ground with many other animals. Now, how can we study the evolution of something so complicated as our minds? The fossil record, of course, is in some sense quiet on this problem because they're not around to tell their tale. But on the other hand, there are some lively things that are left in the past that we can use to understand what was going on. Artifacts, for example, are really traces of a mind from the past. And archaeologists and paleoanthropologists have done some extraordinary work working out the details of things like artifacts. When fire came into existence, when artifacts, tools, art, religion began to come around. Well, I want to sort of push this further back than those guys. And I want to deal with a creature for the moment that is very, very different from us. And I want to bring up this creature for a very particular reason. And it's because in the area of philosophy, and in particular philosophy of mind, people such as Thomas Nagel have thrown out the question, what is it like to be a bat? Or what is it like to be any type of creature other than ourselves? And his answer, and answers that many people have given, is that there is no such thing that's like to be another animal because our sensory world, our perceptual world, is so critically different from that of another animal. Surely it's different from a bat who sees the world, so to speak, with its ears. They send out a biosonar pulse. The biosonar pulse hits objects in the world, and this gives them a menu of possible objects that are in their environment. So how can we possibly understand what their beliefs, their thoughts, their emotions are like if their whole sensory system is so different? Well, if you don't want to buy that bats are a good model for our thinking, well, then I think the primates should probably be a little bit more digestible to you because they're a little bit more closely related. This is the comparison group that I want to talk about today. My daughter, when I showed her this slide, asked me why that one was over there rather than somewhere down here. She's gotten quite sophisticated with her phylogenetic thinking. And I want to, in fact, talk to you today in particular about three species, the three species that I've been working on for the last 15 years, and they're representatives, although I need no means the representatives of their taxonomic groups, and that's the chimpanzees, who are great apes, closely related to the gorillas and orangutans, an old world monkey, in particular the rhesus monkey, very closely related to species like baboons and vervet monkeys that you may be familiar with, and a new world monkey, the cotton-tailed tamarin. Now, unlike some of the people that you'll be hearing in this series who work in labs with robots and so forth, I work in a variety of places, and this sort of informs how I go about thinking about my work. So I want to share a little bit with you right now. The chimpanzees that I study live in a forest in Uganda. It's a tropical rainforest, and the chimpanzees have become very habituated to the presence of humans, so we can watch in detail their behavior. And I'll be telling you a little bit about that at the last part of the talk. Rhesus monkeys, these guys here, the ones I study, they're actually from India, but they were imported in the 1930s to a small island off the coast of Puerto Rico known as Cayo Santiago. And for those of you who think that field research is tough, this is the place that we work on. It's not tough at all. In fact, the pina coladas are somewhere over here. And then lastly, the cotton-tailed tamarin that we study at our lab at Harvard University. Okay. So those are sort of the cast of characters. the outline for my talk today is going to be sort of like a version of Sesame Street, but with hopefully a little bit more content for you. And it's going to be broken into approximately 4 parts. In the first part, I want to touch upon an issue which Anna mentioned at the beginning of today's talk, which is the notion of self. And to try to work out how we could understand whether other creatures have a kind of a self, and if so, whether it's different from ours, and if it's different, in what ways might it be different? And if it's the same, wouldn't that be interesting? The second part is to say, if they do have some understanding of self, can they apply the knowledge that they have to make predictions about the minds of others? Can they mind read in the way that all of you are capable of mind reading every single day? You are constantly making predictions about other people without any experience about what they're doing. You see somebody, they say to you, I have the following religious affiliation. You say, aha, I bet you believe the following. Okay? You immediately jump to that conclusion. Do animals have such capacities? Part 3 will be to focus on the notion of death. Do animals have any understanding of their mortality? And then lastly, taking all 3 of those issues together, I will touch briefly upon the notion of morality to see whether or not animals could possibly be moral creatures in the way that we think we're moral creatures. Okay, so self. This is Tigger from Winnie the Pooh. And Tigger, I won't read through the whole thing, but is surprised to see himself in front of a mirror because he thought that he was the only Tigger in the world. So the mirror for Tigger is a reflection of another. He doesn't get what the mirror should be telling him. Now, is there anything natural about this situation for animals in the wild? Well, yes, there is. Animals often might see themselves in a mirror reflection, and that's water. So there are situations where animals, like these fowl, might have the opportunity to get information about themselves. And it's this kind of reflection that might tell an animal that it is a unique individual. And this might be the beginning stages of the development or the emergence of a sense of self. But how can we get further on this problem? Let me tell you about what I think of as one of the most ingenious experiments I think to ever come out of the field of animal behavior, because it's so very simple. It actually started with Charles Darwin. In the expressions of the emotions of man and animals, Charles Darwin thought to himself, I wonder if animals have a sense of self. And he thought, let's put up a mirror in front of an orangutan, which is exactly what he did. And what he found was the orangutans were interested. They went up, they looked in the mirror. They often looked behind the mirror. And they displayed at the mirror. And Darwin thought, well, based on this kind of aggressive kind of display, it seems that the orangs do not have a sense of self. They think that the mirror reflection is somebody else, in the same way that Tigger did. But it's also possible, which Darwin did acknowledge, that they were trying out their displays, acting aggressively, seeing what they looked like. Boy, don't I look good in that mirror. We can't distinguish that. So along comes Gordon Gallup, a comparative psychologist in the 1970s, who decides that we need to test this a little bit more formally. So he presented the chimpanzees a mirror, a full standing mirror, and he let them watch, and he watched what they did. And they did the same thing that the orangs did. They touched the mirror, they inspected it, they looked at themselves, and so forth. And after exposure to the mirror, he anesthetized the chimpanzees, knocked them out with a drug, and while they were sleeping, he placed a red mark above one eyebrow and a red mark above the opposite ear. And when they woke up, he put the mirror in front of them, and what he found was the chimpanzees directly touched those marks on their eyebrow and the mark on their ear, and not the opposite ones. And from this kind of observation, and others, such as the following, of chimpanzees now beginning to use the mirror to find good things, like picking their noses, flipping their lips up and seeing what they look like, all these body parts they've never seen before. What a revelation, right? Gordon Gallup concluded that not only do chimpanzees recognize themselves in the mirror, in other words, they know that that's me, but they have something much more profound, which is a sense of self-awareness. Now, maybe in the questions we can come back to this issue, but it suggests a pretty profound difference. That to recognize oneself in the mirror seems to me, at least, quite a different type of claim than the claim that they are aware of themselves, that they are aware in some sense of what they believe, and that they know that those beliefs in some sense are different from the beliefs of others. Well, if you work on a species which has been tested in the same type of design and fails, you feel like you've got a really dumb species, so you worry about it a lot. And the one species that we work on, the tamarin, which I mentioned before, this is a little out of focus, sorry. What was a species that had been tested on the Gallup test with these marks on the eyebrow, and they basically fail. And we thought, well, look, why might they fail this test? And if they fail, does it really tell us they lack a sense of self? So we worried about this quite a lot, and we thought, well, look, why might a tamarin fail? Well, one reason why a tamarin might fail is because they have a black face, the red mark isn't really that distinctive. They might not notice it. The other thing is tamarins, like all other monkeys, and in contrast to the apes, like chimpanzees, find looking at somebody else to be aversive. Staring is not good. Staring is a threat. And if staring is a threat, and your first implication that you draw from seeing the mirror is that it's somebody else, then the mirror is aversive. So you might never pick up the details of what a mirror gives you, which is something about real-time coordination between your motion and something else. So we thought, look, we've got to do something really dramatic that will make them pay attention, and that's what we did. We dyed their hair, as Ann told you, and to do this required some very delicate equipment. It required us going to Hubba Hubba, which I'm very sorry to say no longer exists in Central Square, to buy Manic Panic. And we dyed our monkeys with this Manic Panic, different colors, as you can see here. Some had green, some had purple, some had blue and pink and so forth. And we ran exactly Gallup's test. And to our great surprise, when the tamarins saw themselves in the mirror, they also touched their hair. But they did something which to us was far more interesting. And that's sort of shown in one of the few data slides I'm going to have in a moment, which is that unlike what they did before their hair was dyed, the tamarins with their hair dyed now looked at themselves in the mirror for a very long time. So this is what happened to those animals before their hair was dyed, and this is what happens to them after their hair is dyed. They sat in front of the mirror peacefully, without vocalizing, without aggressively displaying, just looking in the mirror. Some would put their hands in front of the mirror and watch the reflection as they moved it round and round. Others would go up in front and check out their backsides. They began to use the mirror in this subtle kind of way. Now, it wasn't as dramatic as the chimpanzees, but it suggests a similar kind of phenomenon, that minimally, perhaps, the tamarins perceive themselves in the mirror as themselves. We think, however, this experiment is completely silent when it comes to revealing anything about what they think about in terms of themselves, what they believe, whether they really have self-awareness. Now, I want to share with you a videotape of something that we recently saw on the island of Cayo Santiago with the rhesus monkeys. This is a population of about 900 monkeys living on an island. No people live there at all. And to our knowledge, they really have not been exposed to any kind of mirror. Well, a few months ago, when I was down on the island of Cayo Santiago, a film crew was there from the BBC, and they were interested in what rhesus would do in front of a mirror. Sadly enough, the mirror broke, so they never got any footage, but we were able to get some because 4 females picked up these fragments of mirrors and carried them around everywhere. Okay, why aren't we going here? We're having technical difficulties here. I'm hitting all the right buttons, but it's not moving. Yeah, it's on A because that lit up the blue screen. So it's the machine which is not going rather than the. Well, that's a good point. Thank you. Talk about human technology. Why doesn't it do it? I'm not from MIT. See, it's the problem.
You're making it self-aware.
Okay. Okay. This is natural footage. This animal's never seen itself in the mirror. And unlike all the claims in the literature, this rhesus monkey is grabbing its fragment mirror and staring at itself at extremely close range while looking in the mirror. Now, this is fascinating for the following reason. First of all, only females did this. Secondly, and more importantly, why in all the previous reports where rhesus monkeys have been tested do they continue to act aggressively? In this case, they don't. Here's one possible explanation. All the other tests are done with full standing mirrors. This is a mirror you can grab around with you. How could you possibly be carrying around another rhesus monkey inside? Impossible. The physics rules out the alternative explanation for them. So we think what's possibly going on here is that the ability to carry around with you your reflection rules out the competing interpretation in the other situations, giving themselves the information that seems to be needed to identify it as themselves. So what we have here is not only what seems to be absolute fascination with their own reflection, but pretty much the first demonstration of a naturally occurring evidence that the animals are interested in themselves in this particular way, and although we can't say this with absolute certainty, what seems to be a clear sex differences. In this population, like in all monkey populations, males dominate females. There'd be no problem for a male coming over and grabbing the mirror from her and taking it. Never have seen this happen. Okay? It's not that it's not possible for it to happen, but we did not see it. Okay. So what I'd like to argue from this first part of my talk is the following, that if we're interested in understanding how certain kinds of capacities have evolved, which I certainly am, and I hope some of you are, then what we need to do is to develop certain kinds of tools, certain kinds of experiments, certain kinds of observations that tell us what's going on. There have been, of course, infinite numbers of pop psychological books written on the mental lives of dogs, the mental lives of animals, speculating on what's going on. And these speculations are interesting because they give us the groundwork upon which we can make more progress. But we have now a set of tools in our hands, such as these, where we can begin to explore in more detail what is actually going on. My conclusion from this part of the talk is the following, that these experiments seem to tell us that the animals do recognize themselves in the mirror. They leave wide open the question of what is going on in their head in terms of their own beliefs. And it's with that sort of claim that I want to turn to the second part of the talk, which is what is going on in their heads and how can we find out? In Magritte's painting here, it's interesting, of course, because we know what's going on in the mirror, and he's sort of flipping the mirror image around. And we can understand that because we can form a representation in our own minds, in our own mind's eye, about what the reflection should look like. The capacity that we have that I referred to at the beginning of my talk, which was the capacity for mind reading, is an incredible tool. We can sit here and embed intentionality and embed beliefs at an extraordinary level. Little Charlie here can have a thought Z, and little Susie can have a thought about Charlie having a thought Z, and little Bill can have a thought about Susie having a thought about Charlie having a thought Z. And we can go on forever like that almost. And this capacity allows us to navigate in the social world in a way which is extraordinary. And what's so interesting about this is it seems that certain parts of our brains are really responsible for this. And we know this from a number of different avenues, but one in particular which is so telling is something like autism, where there's a complete breakdown, in many cases, of this capacity to realize that others have minds and others have beliefs that are often very distinctive from our own. What about non-human animals? And how can we find out? We don't have language. We can't ask them with language. So how can we tell? Let me tell you about a very simple but elegant experiment that's been run on a large number of normal children and also run on autistics, and then tell you about our version of this experiment that we run in our lab at Harvard with the cotton-top tamarins. It's a test which tries to ask whether an animal or whether a human animal can understand the notion of a false belief. This is critical because when things happen that we don't witness, we have a belief that may be very, very different because of the transaction that happened in our absence. Here is the experiment. A child watches a puppet show between two puppets, Sally and Ann, Sally in blue, Ann with the polka dots. And they're playing with a ball, and Sally puts the ball into the blue box and says, I'm going to go outside and get something. I'm like, come back in, let's keep playing. So she splits. While she's gone, Ann takes the ball out of the blue box and places it in the green box. And now Sally comes back in, and you ask the child, where will Sally look for the ball? Now, if you understand what's going on, and you understand that Sally can't possibly know that it's been switched, your prediction should be Sally's going to look in the blue box. But if you think your worldview is shared by everyone, your prediction will be that she's going to look in the green box. That's wrong. That means you don't understand the notion of false beliefs. 3-year-old children say that Sally will look in the green box. 4-year-olds say the blue box. Autistics say the green box. There's something going on here developmentally and neurologically. But here is a fascinating twist in the story which gives us our in to this experimental procedure. You ask the 3-year-old, where is Sally going to look for the ball? The 3-year-old looks at the blue box and says the green box. The 3-year-old seems to be predicting accurately with its eyes, But something goes wrong when language comes in. The authors of this work, Clements and Perner, suggest that the reason why something goes wrong is because without language, they're making implicit or covert representation of what's going on, but language forces them to entertain the two hypotheses for where Sally might go explicitly. They must make a concrete representation in their mind about what the alternatives are, and somehow language is screwing things up. Now hold that sort of possibility in your mind for the moment, but now just think about this. The eyes are telling us something about what's going on in the child's head. And if that's true, then the eyes of an animal should be equally telling. Okay, so we use the eyes of our tamarins to tell us something about false belief, and we borrowed a technique which was developed within developmental psychology. And the technique uses a little bit of magic. And the idea is this. Why is magic so interesting to us? Magic is interesting, and special effects are interesting, because we're constantly being faced with violations of the way the world works. Physical principles are being violated. Bodies sawed in half, bodies levitating, people's faces being stretched all over the place. Whatever it is, it's a violation. It's interesting. Now, infants don't necessarily come into the world with an understanding of that, but if they do, then they should be as surprised and should look as long at those violations when contrasted with things that are consistent with the world. That's the logic behind the experiment I'm going to tell you right now. Here was our version of the Sally Ann experiment. An actor would come into a room while a tamarin was seated in a little transparent box, and an experimenter stood on one side of the table. The actor came in chewing some apple, placed the apple on the table and gave the tamarin some, shared some apple, and then placed the apple in one of the opaque boxes, let's say box number 2. And then the actor, in the first condition I'm going to tell you about, leaves the room. Now in this first condition, the boxes are transparent. You can see where the apple is. And now the actor comes back in. But before he does, the experimenter moves the apple from the box number 2 into box number 1. Now the actor should be thinking, coming in, the apple was in box 2, that's where I left it. But now he should search in box 1 nonetheless because he can see it. So the violation in this situation is searching in box 2 if the tamarins think the actor wants the apple. But now we run the controls for this procedure in the next 2 situations. In the next one, now the boxes are opaque. And now when the actor leaves the room and the apple is moved, now looking in box 1 is a violation, whereas looking in box 2 is consistent. And then the final control for this is that now the actor stays in the room with the opaque boxes, and he witnesses the apple's movement from box 2 to box 1. Now you reverse again the expectation. Now looking in box 2 is bizarre. Looking in box 1 is appropriate because he saw it move there. So in each case, the actor's action is exactly the same. The only thing that differs is what the actor should or should not know. And all I'm going to show you now on the next slide is the last data slide, which is what the tamarins do in terms of how long they look. And here's what we find. This is the amount of time they spent looking. These are the 3 conditions. Transparent box, actor leaves. Opaque box, actor leaves. Opaque box, actor stays. No difference at all with the transparent box condition. Now, for some of you, you may think this is a failure. And it's possible that it is a failure. But another way of thinking about this is as follows. The tamarins love apples. Apples are fascinating. And they're particularly fascinating in this situation because the actor gives them some. So certainly reaching for the box where the apple now is and they can see it is interesting because it's likely that they're going to have some apple. But for some reason, they find it equally interesting when the actor searches in the box where there's nothing. And more importantly, in some cases, some animals, they would look at the actor opening this transparent box and then look back at the apple, desiringly perhaps, and then come back to the transparent box. So this was equally interesting, but we couldn't pull apart the difference. Where we can pull apart the difference is in these 2 conditions. And this is critical because it suggests the possibility that what the tamarins are doing is representing what the actor must believe. Here, looking in the box where the apple now is unexpected because the actor can't know it's there. Here, looking in the box where the apple now isn't is bizarre because they saw it moved. So their looking time of these animals seems to be telling us something at some level about what they know. And it suggests the possibility, a first possibility, that tamarins have some notion of a false belief. What's unclear is whether it's the same kind of understanding that a 3-year-old has, which is implicit, covert, they're not quite aware of what it is, or whether it really is a form of explicit knowledge. We just can't tell. But this is the beginning. And this is an area of research which is extremely in its infancy. We know very, very little about what animals believe, what they know. So what I want to do is I want to leave you at this point of the talk with a suggestion, a hint, that non-human primates may have some understanding of beliefs. They may have, in the words of David Primack, a theory of mind. They may have some capacity to mind read. Let me now turn to the third part of the talk. Death is something that is on most people's minds at some point in time in their life. It takes on all sorts of different configurations and properties in terms of what people believe about death. Whether you believe in the afterlife, whether you believe that certain things should be done following on the death of somebody. In Uganda, for example, a place that I work, when somebody dies, there's a 3-day ceremony. The first day is a day of mourning. People come from all over, relatives, friends, to the ceremony. It's a full day of mourning. And then after that, it's 2 full days of parties. And the reason why, in part, there's this change from mourning to partying is because many of the people that have come to the funeral, they haven't seen for a long time. In fact, they may not see them for a very, very long time after everybody leaves. So they both want to think about the person who's just died, but they also want to enjoy the people who have come. So beliefs change all over the place, depending upon people's cultural values, depending upon one's beliefs, and so forth. And this is very flexible. But what people can agree upon at some level is that when somebody dies, there are certain things that happen that are very different from when someone's alive. Do animals have any understanding of this? Would they be able to make a distinction between somebody in a trance like this, who in some senses lacks the key vital signs, and somebody who truly is dead? If I'm walking down the street and I see one of you and I say hi, and we're good friends and so forth, I say hi, and then 5 minutes later I find you flat out on the floor, check your breathing, don't detect anything, you're not really breathing at all, I can't smell anything from your nose, call the ambulance, they say, sorry, she's dead. I'm terribly sorry. And then 5 minutes later I see you in the street again. And I go, wait a minute. I said, I thought before you were just like dead. And you say, well, no, I'm actually not. And so I'm fine. And then a few minutes later, I find you again laid out. Now, my second encounter, I'm not going to trust what I thought the first time. And I think, okay, this person is just something's happening here. And my beliefs are going to change. And they're going to change in important ways. And they're going to change in important ways because our conceptual apparatus is built in such a way that we can take on new experience and modify what we believe. Let me give you a complete opposite situation. Ed Wilson at Harvard, who many of you, I think, have come to know through his work on sociobiology, but is also one of the world's experts in the study of ants. And Ed Wilson discovered something very important a long time ago in the 70s, that when ants die, they are dragged out of their colony. And what he wanted to know was, well, what is the mechanism by which they recognize dead ants from living ants? Well, it turns out that when an ant dies, it emits a chemical called oleic acid. And if you take oleic acid and you put it on a live ant, they are dragged out of the colony kicking and screaming. For an ant, therefore, dead equals oleic acid. It's very simple. It's a lock and key system. It can't be modified. They don't seem to learn at all from this kind of experience or from the person who say, excuse me, I'm still alive. That's a different kind of concept of death than certainly what we have, even though we can have hopes for people coming back, even though we can think that there may be all sorts of things that will change. Let me tell you now about a couple more cases of animals responding to death, which will now build up a picture which is perhaps a little more complicated than what we see in ants. Now, here is this a recognition of death. Monkey hear no evil, see no evil, speak no evil. Clearly recognizing something's going on that's different, something that's wrong. Animals certainly age. On the island of Cayo Santiago, we have many, many old animals that change, that become lethargic, arthritic, lose a lot of their sensibilities. Presumably are coming to the end of their lives. Is there a change in the way they think about their current lives? Do they reflect upon their past? Do they wonder what it would be like not to be around anymore? In elephants, there are stories, some of them true, about what elephants do when another individual has died. This is a slide taken from an animal, a young individual that I took when I was living in Kenya, who was not going to make it. In fact, the infant died at the end of this day. This is a slide of its mother trying to basically pick it up and move it so it will walk. it would sort of get up, stumble down, and fall over. And the mother, with its trunk, and as you can see here, with its leg, would sort of kick it and try to get it to go. And it wouldn't work, and eventually the infant died. And what's been reported in the literature over and over again is that elephants will come back to the dead individual over and over again. In fact, will come back to their dead bones, pick up the bones in their trunks, manipulate them, come back, sit very solemnly, very quietly, and looking at the pile of bones. What is going on in their heads? We can invent all sorts of stories, but it's really not clear what is going on in their heads. And if you're interested in what's going on in their heads, then we need to take these observations much further. Let me tell you one example of this. These are the vervet monkeys that I was studying in Kenya. The vervets, this doesn't seem to focus at all, so sorry about that. In any case, the vervet monkeys are a small old world monkey, closely related to the rhesus monkeys. And in this population, the following experiment was done to see whether mothers could recognize the voices of their infants. They played back a vocalization that infants give when they're distressed and separated from their mothers. And they played back this call through a speaker to a mother and two adult females. And when the call was played back, the mother looked to the speaker and the two females looked to the mother, suggesting the possibility that the females understand the relationship, that is that mother's kid. What is she going to do about it? Okay. The point I'm making here that I want to anchor is that the infant's call has a kind of a signature. Well, during the 2 years that I was in Amboseli, working on these vervet monkeys, 7 infants died whose vocalization, that particular vocalization, I recorded before their death. And I played it back to mothers 24 hours to 48 hours after the infant's death. Now, for some of you probably think, God, what a bastard, what a terrible experiment to do. But think about it. Think of the assumptions you've just made in criticizing me. So I preempted it already. We don't know what they think. Here is the result. 7 females play back their call. Nobody responds. Zippo. Nothing. Nothing was going on at the time I played the call back. The females were all resting, sitting peacefully, quietly, eating in a tree. The call went off. Not even a detectable flinch. Now, what's the mechanism here? Is it out of sight, out of mind? Possibly. This is 24 hours later. In the life of a vervet infant, infants are never away from their mothers for more than about 2 hours. So 24 hours, it's gone. And predation in this population is massive. 70% of the kids never make it to their first birthdays. So it's very likely that a mechanism would have evolved in this species for out of sight is out of mind. So maybe we're a little bit closer. At least we've got one possible mechanism going on that would make them respond to death in certain kinds of ways, but maybe it's no different than what the ant does. What would happen if we brought the infant back and then played the trick again? Like in our discussion of walking through town and seeing somebody who was passed out twice in a row. Would they change their minds? We don't know. But now let me show you another videotape from a species where there's a little bit more compelling, possibly evidence. It's in part because it's a documentary and there's music behind it, but I want you just to watch the response of this female chimpanzee.
Since her baby is too feeble to cling to her, she resorts to carrying it with her foot as she climbs in search of the food she needs to survive. Still, the baby clings to life.
How do we really realize that somebody's dead? How would we realize if we didn't have all the signs, all the things? So, I think in a way they certainly know that something special is happening, that they would like to fight against it, but that they can't, and they realize it after a while.
Finally, the emaciated form of her infant lies deathly still. Then, with a gesture so human it's painful to watch, she seems to bid her baby farewell with a kiss. chimps share with us the...
I probably should be hanging out handkerchiefs or something, probably. But so the point I'd like to make here in this juncture of the talk is that we have these fascinating observations, these observations that are so compelling to us, but they're compelling to us to a large extent because we are unavoidably empathetic creatures. We can't turn it off. We see something that even looks close to what it means to be human, and we immediately jump to the conclusion that it must be feeling or experiencing the kinds of things that we do. And it may be true that what the chimpanzee is feeling at the moment when it experiences its own dead child, that it experiences very much like what we experience. And certainly, given the close evolutionary proximity between humans and chimpanzees, it seems like a reasonable interpretation. But the problem is that behavior can often be a very misleading guide to what's going on in the heart and what's going on in the head. So what I would like to do now is turn to the last part of the talk and talk for a moment about emotions, and talk about emotions as being the central core to our thinking about morality and its evolution. Let's take something that is a very late developing emotion in the child, embarrassment. Embarrassment is a critical emotion if you are going to be a moral creature, because it suggests the possibility that if you feel embarrassed, you have some feeling of guilt, that you've done something wrong, or that you're embarrassed by your action. It wasn't quite appropriate, wasn't quite right. We see cross-culturally that the expression of embarrassment comes in very similar forms. There's a covering up of the face, there's a hiding, deflecting the eyes, and so forth. Do animals show embarrassment, and how would we know? Is this rat embarrassed? Now, we don't think that the rat is embarrassed, but how would we find out? Behavior could be very, very misleading. Let's take something that looks a little bit more like what we do. When chimpanzees are attacked, and when other non-human primates are attacked, they often scream. They scream very loud, they retract their faces, they retract their lips, and they show what we call a fear grimace. It's a very characteristic sign. It's very dramatic and exaggerated. But what happens in some primate species, and in not very many non-primate species, is that following a fight, animals reconcile. They make up for what's going on. They make up in very interesting and very human-like ways. This is that same individual here who now comes over to the dominant who just pummeled it and offers its hand to its mouth as a gesture. And this is a sign of trust. I could bite you, but I'm not going to. The fight's over. Let's get back to business. Males will come over, who have just been beaten, a low-ranking male, will come over to the high-ranking animal and offer their testicles to the male, who will hold on to them gently. This is trust, as the word comes from, testament. This is trust, and it's done to keep levels of aggression down. It is a mechanism that keeps peace within a society. And we see it in spades within the chimpanzees. We see it in lesser degrees within other non-human species. So these are the kinds of things, these are the kinds of emotion and kinds of ways of dealing with emotion that would seem to be at the root of our moral status. Without these kinds of emotions, it seems impossible to evolve a moral society. Now, what I want to show you as the last clip and then sort of last bit of discussion is a fantastic case recently that many of you, I'm sure, have heard about, but you probably haven't seen the footage from. And it's a fascinating case of a boy who fell into a gorilla enclosure at the Chicago Zoo, and it's the response that the female gorilla, shown here, Binti, did when it discovered this young boy. This was taken by a person who was just at the zoo.
Chicago's Brookfield Zoo. A 3-year-old boy falls into the gorilla's enclosure, knocking himself unconscious. injured child, cradles him, and brings him to the cage door.
Well, here we see Binti Jula, the female, the one who picked up the boy. The boy was unconscious when she picked it up. She transported him very gently over quite a distance to an area where people could get access to the boy. And so she was considered rescuing the child. Without her, there might have been a lot more problems with it. And the boy survived afterwards.
In carrying the boy to where humans could reach him quickly, Binti also prevented the other 6 gorillas from hurting the child. But did she really intend to save him? Or did she pick him up because he was a curious new object? It's a subject of much debate.
And the debate part was going to be me responding, so I'll just do it in live. Franz de Waal, who you heard describe the phenomenon, falls in line with many others who have described the phenomenon, talking about it as the gorilla rescuing. This is a possible interpretation. It is possible certainly that Binti, this particular gorilla, had some feelings, some altruistic feelings towards this child, to protect the child against the other gorillas. But there are alternatives. And if you're interested in what was going on in Binti's head and in her heart, then these alternatives must be seriously entertained. We know that animals living in zoos have a long history of interacting with their caretakers. It's possible the caretaker trained Binti to bring over any object that was novel, that was falling into her cage. So would Binti respond in the same way to any object that fell into her cage? The zookeeper apparently heard about my snippy remark and said, well, look, I once dropped a bag of potato chips in, she didn't bring that over. But that's not the point. Would she respond the same way, if you could possibly do the experiment, you probably couldn't, to a live child? How would she respond? Would she respond the same way to a teddy bear? In order to understand what Binti was feeling and what she was thinking, these are the kinds of things you'd like to at least entertain as possibilities. Now, let me tell you in sort of conclusion now, two experiments that I think get us a little bit closer to a sense of morality, in particular a sense of empathy. Because what's really being questioned in the case of Binti is, did she feel empathetic towards this child? And is that why she did it? Quickly, here's the experiment. 2 rhesus monkeys are trained to press the button or bar here when the A light goes off to avoid being shocked. And they press the other lever under the B light to get food. And they learn this very, very quickly. And these are 2 cage mates. Now here comes the interesting experiment. Fred over here is put into an enclosure visually isolated from Sam. And Fred sees 2 lights, but he has no levers. There's a video camera filming Fred's face. Sam over here has no lights, but he's got the levers, but he has a video monitor showing Fred's face. He learns it like that. He presses the correct bars, and both avoid getting the shock, and both get food. If you put in an unfamiliar individual over here, it doesn't work at all. Now, it might not work for 2 reasons. It might not work because Sam has no way of reading the face of an unfamiliar individual. He doesn't know what's going on. You can't quite argue that it's spite because, of course, he gets shocked too. But now let me tell you about one more experiment which is even more interesting. A rhesus monkey is put into an enclosure, and on the other side of the enclosure, separated by a plexiglass partition, is another rhesus monkey. When the one on, let's say, the right-hand side goes to reach for food on his side of the enclosure, the other guy gets painfully shocked. This rhesus monkey will avoid eating food for 3 to 4 days. Now, this is fascinating. He is incurring a major cost of food deprivation because reaching for food gives pain to the other. This opens up all sorts of questions. Would they respond the same way to an unfamiliar individual? What about another species? Would they care in the same kind of way? Would they generalize the way they feel about a cage mate to others? These are the kinds of experiments that I think tell us a lot more about what's going on in the hearts and heads of these animals than the kinds of observations that are useful as groundwork, but then must be further followed up with other kinds of experiments. So let me conclude then with the following statements. We have an extraordinary curiosity about intelligent life forms outside of the planet Earth. And we spend millions of dollars in searching for it. And yet we share a planet with a species that is extremely closely related to ours, and we spend very little money on it. This is peculiar. This is an intelligent life form. It's a very intelligent life form, and in many ways it shares many things in common with us. I think we're at the beginning now of an appreciation of what the minds of other species are really like, what they feel, and what they believe. I don't have time to show you today, but there are some interesting cases now of what people might want to call a rain dance in the chimpanzee. That when the rain comes out, Jane Goodall has described a case of chimpanzees sort of going into euphoria and dancing around. Is this the beginning of ritualized dance? We also have cases of animals chorusing together the beautiful melodies of songbirds. These rituals, these melodies, these conventions, are these possibly the roots of our own culture? These are the kinds of questions that I believe that with future studies of animals, what they feel and what they think, will give us new insights into how our own cultural systems evolve. Thanks.
Thank you, Marc. Are there any questions? Or, yeah, I guess so. Do you want to take your own questions?
Sure.
Or? Okay.
Yeah.
Just on the issue of theory of mind and autistic, and it's just worth mentioning there's a lot of discussion and some controversy around what that means, including among autistics. Many of whom reject what that means, and many of whom are in touch with each other, for instance, by means of the World Wide Web, through which they evidence tremendous empathy and understanding of each other. So there's just questions about what that means. I just want to say to absolutely eliminate autistics from having the theory of mind is not, it's a little questionable.
Well, I think I was careful to say, maybe I wasn't, you can correct me if I'm wrong, I said some autistics. And it's absolutely clear that some autistics are absolutely incapable of passing these tests. So I hope I didn't say it, but if I did, I'll correct myself now and say that the claim was for some autistics, where there are now possibly some diagnostic tests for what might be going wrong neurologically, of actual deficits that seem in very many ways to parallel the kind of deficits you can see with lesion studies in rhesus monkeys. Let me just give you one quick example just so I can clarify what I said. In rhesus monkeys is a part of the brain that seems to be very much involved in the detection of eye gaze and understanding what eyes mean. And one of the problems some autistics have is understanding what the eyes tell us. That seeing as knowing for many autistics is opaque. If you lesion that area out of a rhesus monkey, they don't discriminate on the basis of eye gaze. Okay? Some studies are revealing now that those seem to be areas that in some autistics to fail those tests is damaged. Okay? So yes, by all means, there are very high functioning autistics. Temple Grounding, the vet, is a perfect example of that. But if you saw the New York Times article, she herself mentioned romance novels. What a mind-boggling concept, right? So even in very high functioning autistics, there is this kind of problem. So all I wanted to say was that for some autistics, okay, and clarify, that problem of theory of mind is clearly not something they have a grasp of. Yeah?
You mentioned in the last sentence that the chimpanzee and the rain comes in this start to dance. While growing up in India, when we were kids, when the monsoon came, we did the same thing. We went up rain dance. It had nothing to do with any ritual. It was because it was relieving. It was, kind of release from the hot weather.
Yes, no, yeah, it was kind of a throwaway line, but the one thing I would say is the following, that many things that have become ritualized in animal behavior grew out of just exactly that, of certain kinds of emotion. For example, the dance of the honeybee, which you may be familiar with, grew out of an intention movement to fly, which then became ritualized. And what we see over and over and over again in non-human animal societies is that expressions of emotion often become ritualized and conventionalized. So I was throwing out the rain dance as possibly a case of euphoria and jumping around that could be conventionalized. Yeah?
Distinguishing between ritualized behavior, implied learned behavior, and separating genetic predispositions and sociobiological concepts from learned behaviors and empathy. Is there a genetic predisposition for that kind of display of behavior? How much might it be influenced by learned behavior or obliterated by learned behavior? An issue which I don't think we should really touch.
Yeah, the question was whether some of the issues that have been discussed, like empathy and ritualization, are based on genetic predispositions or whether they are learned behaviors. That's an immense question, a very profound question in many ways, and I would like to answer it, I guess, in sort of two small bits. One is that my own view, which is, I think, shared by some people, at least within the cognitive sciences, is that we don't want to set up this dichotomy that we kind of have lived over and over again since the 60s and earlier than that. And we want to entertain the possibility that there are genetic predispositions to learn, that there is an instinct to learn, and that what our genetic biases give us are attentional foci onto certain kinds of experiences, that we attend to certain things. And that's as true of us as it's true of any animal. So what experience can do to move the system around, possible degrees of freedom, that's open for all these kinds of problems. So what I would like to then say is that, is empathy genetic? I have no idea. I mean, with what extent it is. Are there genetic predispositions for certain kinds of emotions? Yes, we know that. And in fact, if you look even within certain primate groups, like the macaques, which there are many species, there are clear temperamental differences, which are genetic. And you can move those around a little bit, but only within a certain range. Rhesus monkeys are really aggressive macaques. Barber macaques are really kind of nice, and stump-tailed macaques are even nicer. So I think the only point would be to say, we don't really know yet how much the genetic contribution is guiding these kinds of experiences and how flexible it is. Yeah?
Do human children show the same fascination and surprise at the reflection in the mirror as the
Children pass, so to speak, the Gallup mark test at the age of about 18 to 24 months. Okay? So it's quite delayed, because if you think about it, an 18 to 24-month-old, a 2-year-old, let's say, has already got some language. They're producing words, they're comprehending words, they're even beginning to string words together syntactically. That child, however, does not have at least a mirror self-recognition. They do show fascination with mirrors. The chimps, I think I probably should have said this, the fascination with the mirror is a somewhat short-lived one. That it's the initial hit with the mirror that initially sets off this kind of looking into the mouth and so forth. And then it dies down pretty quickly. So children also will show a kind of peak in interest early on. And then, of course, it changes as they get older. The other comparison, which is quite interesting, this is maybe just a short report on another experiment, is the chimpanzees also have an extraordinary capacity to navigate spatially by using a video monitor of their arm moving when they can't see where it's going. A capacity that we find very difficult when you walk into a department store and you see a video image of yourself, it's not really clear where you're going. Chimps almost automatically will figure out the spatial coordinates through a video monitor. There's a sense of awareness of spatial movement about the body that's very, very refined in the chimpanzee. So, and that kind of experiment actually has not been done with children. So there's a lot of areas where the comparisons haven't been as well sort of, done. Yeah?
You know Lacan's higher lateness? The vision of Jacques Lacan's thing about the young person who sees himself in a mirror.
I don't.
And it's the beginning of consciousness.
Okay.
But the thing about it is that it's the beginning of consciousness. It's the aha erlebnis, this first experience, which leads to the development of the ego, etc. And I'm wondering if there are, it would be interesting, or if there have been long-term experiences with primates where they live with that mirror for a while. It would seem to me wouldn't it evolve? Isn't that an interesting question?
It's a fascinating question. In fact, I've just been, it's interesting you mentioned, I've just been writing about this, and we don't know, for example, whether upon contact with a mirror and now being given this information, whether it changes their personality. Have no idea how this might alter the personality of an individual. Now, the people who have done this work don't think that the mirror is giving them a sense of self. They think it's already there. They think of the sense of self as being amodal, not being restricted to the visual modality. But the thing that's interesting about this also is that the mirror test is somewhat misleading in the following way. Some patients who have damage to the visual areas experience this deficit called prosopagnosia, which some of you may know about, which is that they fail to recognize familiar faces, but they can recognize all other visual objects. It seems to be restricted to the face. And in some of these cases, it includes their own face. Now, these people have no problem telling you who they are. Okay? It's not a loss of self at all. So in one sense, you could see the mirror test as a very misleading test in terms of notion of self, because on that basis, the prosopagnostics fail. So that's why I try to make the distinction, which I think you're getting at in terms of the awareness and consciousness, between self-recognition on the one hand and self-awareness. And I think those tests are simply mute on that problem. And nobody has yet come up with a better experiment. I mean, the false belief experiment begins to get at something like that because you're comparing what you know with what somebody else should know. But it's also possible, if you're interested, we can talk about it later, to pass the false belief test, like I showed, without really any recourse to the mind at all. You could just be a good predictor of behavior. So there's even problems there. So nobody's really come up with an elegant test yet to determine what is going on in the animal's head in terms of any kind of awareness of that. Yeah?
You said that the monkeys didn't pick up the broken mirrors. No. Are there any guesses? Did the females happen to be there quicker?
No, the mirrors were all over the broken fragments were everywhere. The second thing, which I'll just repeat, is that the males are dominant, and if they wanted the mirror, they could grab it away. But the third point, which I think is very interesting, is that if you look at the literature on tool use in animals, it's always the females. They are the inventors, and they are typically the users. In a population of chimpanzees in Sierra Leone, the chimps feed on this fruit from a tree called the kapok tree, which has these huge thorns, and it's very difficult to get the fruits. The females have invented what the authors call sandals and seats. They strip off bark, and they put them on their feet, and they climb up the tree like crampons, and when they get to a good patch, they put some more under their butts, and they sit down and eat peacefully. Only females. Now, so repeatedly, the inventors seem to be the chimps, and often, the females, and often the users are the females as well. And it then spreads slowly. The classic case, right, of the potato washing Japanese macaques, the adult males were the last ones to get it. The females got it first, especially juveniles, and then lastly the adult males. So I have no idea. Now, I would say that in the rhesus monkeys, like all monkeys, females are the really social members of the society, and males are much less social. It's the reverse in chimpanzees. But in monkey societies, females are close-knit social groups, and males are very distant related and don't interact very much. Whether that has anything to do with it, I don't know. Yes?
Your experiment with the video camera and the shocking. Now, you said unfamiliar...
It wasn't my experiment. It was actually all experiment.
The unfamiliar individual, same species?
Unfamiliar individual of the same species. The whole thing washes. Yeah. This was an old experiment. Actually, both experiments I described, one was done in the 50s and one was done in the 60s. These experiments could not be done anymore because of the ethics involved in shocking primates. That said, the results they got were that unfamiliar animal, the whole thing washes. They didn't do the other experiment where you had reaching for food and shocking. They only did somebody that they knew. No, this is sorry. I described two experiments. One was with the levers, and that one was done with the familiar cage mate, Fred and Sam, and unfamiliar. The other one with the glass partition and the food, reaching for food and being shocked, that one was just one animal, yeah. Yeah?
I read in an article that cats and dogs have an IQ of about 14, but from what you've described, it doesn't seem like we could test animal intelligence anywhere near that, accurately. Where that number comes from, what it means.
The question was an article purporting that dogs and cats have an IQ of 14. How can we test for IQ in animals? I don't know about the claim for IQs of 14, but let's take the more serious question you asked, which is, can we test for intelligence in animals, which is a very important question. I think it ends up being the same kind of questions that people will often argue for the IQ test. Is IQ test a test of intelligence in humans? And I think the point I was trying to make at the beginning, and maybe I didn't make it as elegant as I could have, is that the question of intelligence is really a question about specialization given the environmental pressures that an animal confronts. And so to say, let's give a test of intelligence that we think are intelligent behaviors, well, let's ask us to echolocate and find objects. Are we going to do well? Well, actually, no, we're not. Okay? So the point is, the test has to be sensitive to what the animals are doing. And when we make claims like, for example, look, we really think the chimps and the dolphins and the gorillas and the orangutans and the parrots are all smart because they have big brains, that's a mistake, I think, in thinking. Because, first of all, it's not necessarily the size of the brain that's telling us very much about intelligence. And secondly, it has to do with specializations of the parts of the brain. In the bat, almost the entire brain is dedicated to the auditory cortex. Why? Because the bat's world is the auditory world. That's all it cares about. So asking a task, can you please separate these objects based on your vision? It's not a good test. Okay? So the point is that what does seem to be happening with dogs and cats, and this is an interesting issue, is that certain kinds of tests that we know are not problems for dogs and cats based on their motoric skills, there is a difference between what dogs do and cats do. And some of the interesting intuitions there have come from thinking about the ancestors to the domestic dogs and cats. Cats are asocial animals, dogs are social animals. In terms of social intelligence, okay, dogs are far smarter, but that makes sense. Think about their history. So I think that question has to be bounded in terms of the social behavior and ecology that the animal has confronted in its past, the kinds of regularities it confronts, which would have favored certain kinds of abilities over others. Yeah?
About 3-year-olds and the rhesus monkeys will choose the box which goes against what they visually know. And language somehow impedes. Wouldn't you think, why would it impede? Wouldn't it just be kind of you'd expect a random, they pick one box 50% of the time, the other 50%. What basis would you say the language impedes, conflicts with what they visually know? It doesn't make any sense to me. I missed something, I think.
Yeah, okay, so the question is, in the false belief test with Sally and Ann, what is the issue going on between what the 3-year-old child seems to be telling us with their eyes and what they seem to be reporting with their language? What I was reporting on is a distinction that the authors drew from their own results. The interpretation they give is that when the child is merely scanning the scene, what they're doing is making a simple prediction with their eyes. And they seem to be making the prediction correctly. When they're being asked, where will the puppet go, they're being forced to entertain one possibility over another, and for some reason, which we don't know, they're making the wrong decision. They want to argue, and I'm not saying this is necessarily the right argument or the right conclusion, is that it's something about using your language to keep those two ideas in mind and then report on them explicitly that is somehow throwing them off. They don't understand the mechanism or why or anything. They are merely speculating about one possibility. And the idea is simply this. We know there are a number of cases where what you know, you're not aware of your knowledge. And there are other cases where you can repeat to me that you are aware of it. Okay? And let me give you an example of something we just talked about. The prosopagnostics patients who lack the ability to recognize faces, that is the lack of ability is to say, that's Fred, that's Ronald Reagan, that's Marilyn Monroe, or whatever it is. Okay? But if you record from their skin or if you record from their heart, they show familiarity at that level. That's the distinction between being aware of what you know and not being aware of what you know. And the interpretation for the children is that they're not aware that they know what the correct answer is. That could be. Or it could be that when they get older, they think you want a specific answer. And they're going what they think you want. Okay? That's one interpretation. Your question is right in the sense that we don't really know what makes the difference between a 3-year-old and a 4-year-old. Okay? Or what makes the difference between reporting with your eyes and reporting with your mouth. But the observation sticks as an observation of a difference in the accuracy of the prediction. And it's very distinctive as well. Yeah?
This won't be as brilliant as some of the other questions, but you keep using the word intelligence. Like you said, they show social intelligence, or that they have intelligent behavior, or that we're looking on Mars, when in the monkeys we have intelligent behavior. What is it about the monkeys that makes you think that they're intelligent?
Oh, okay. I don't think actually I used intelligence the entire talk, but I was responding to a question about intelligence. But I think that the notion of intelligence, I would sort of translate that into what kinds of skills the animal brings to a task that allows it to solve that task. And that in the domain of social behavior, primates, due to the pressures of being in a social group, are more sophisticated in the following kind of way. And I can operationalize it if you want. Due to the pressures of living in a social group that's like a primate social group, what you see in primates, but you do not see really in other animals to the extent, is coalitions form, where animal A will join together with animal B to beat up animal C. Okay? Now, that capacity requires you to do a number of very important things that are difficult. You have to keep track of what you know about rank relationships, what that animal's rank relationship is, whether they will help you under certain circumstances, and if not, what will happen. Okay? Now, it gets outrageous in dolphins, where dolphins will form these super coalitions. 2 or 3 males will join up with 2 or 3 other males against another coalition to gain up and get a female. Now, that's complicated in the sense of what you have to remember. Okay? Now, I don't care personally to say that's more intelligent than a honeybee who can go off at a distance of 300 meters and come back and say, at 300 meters to the northeast is precisely the food you want to go get. That's bee's intelligence, if you want to use the word. So I rather actually not use the word intelligence, talk about specialization. So in that sense, the bats are specialized for echolocation. It doesn't make them more or less intelligent. Yeah.
On the issue of animal morals, I don't know the literature very well. Are there any examples of animals acting morally in a case where it would be their advantage to do otherwise?
Okay, the question is, are there any examples of animals acting morally in the case where there might not be any advantage to doing so? The distinction I like to make, and I'm sure that lots of people will disagree with this completely, is the following. That in order to be a moral creature, it requires the notion of agency, the requirement to act intentionally. Okay? I don't think we've got any evidence yet that suggests that animals act with intention. They act in sophisticated ways by recognizing differences in behavior and so forth. So the distinction I'd like to make is that we see lots of behaviors which are sensitive to the behaviors of others. And in that sense, I would like to say that animals are moral patients. They sort of are deserving of our moral treatment. But they don't act moral because they can't make a distinction between what's right and what's wrong. At least we haven't been able to show that they do. I leave open the possibility that that's true. That said, there are lots of behaviors which look moral. Okay? I mean, Jacques Cousteau reported many, many times, diver drowning and dolphins picking up the diver, bringing it up so they could breathe. Moral? On the count that they're intentionally doing it, yes. On the count that it's something else, no. So I think the distinction I like to make is that until we can understand the extent to which animals can act intentionally and be agents, aware of their actions and distinguishing right and wrong, we can't make the claim they're acting morally. Yeah?
On the issue of theory of minds, of other minds, I've noticed that my cat is very good at noticing things that I look at. At what level of, having a theory of another mind would you put an animal that is able to understand or be interested in what another person or animal is looking at?
Yeah, that's a good question. The distinction that I didn't make clearly enough is the following. Many, many animals will follow the direction of eye gaze. That's a highly adaptive behavior because vigilance is so critical to most animals who are preyed upon. Okay? So vigilance and eye scanning, lots of animals. No need for theory of mind there. Now, the experiment I told you about with the tamarins, the part I didn't tell you about because I don't want to tell you all the details, here's the part of the experiment the tamarins fail. I told you that they look longer when the actor looks in the box where the apple is if they've been out of the room. Okay? They seem to make the correct prediction. That's bizarre because I should know where it is. Now just make the following small changes. Rather than my leaving the room, I stay in the room but I close my eyes. They fail. Or I turn around 180 degrees. They fail. They seem to need absence to understand what's going on in terms of the expectation of the actor. Okay? So that's a sense in which the tamarins do not understand that seeing is knowing. They seem to understand, or at least this is suggestive, that absence means can't know. So it's a much more coarse-grained analysis than what we're capable of doing. And again, I can tell you, if you're interested after, there's similar examples of this in chimpanzees, where they seem to also fail this expectation. In addition, autistics, some autistics, again, have this kind of failure. Here's a very simple experiment. With some autistics, if you do the following experiment, they fail. 2 people standing in front of a big open box. One person looks in, and the other person looks straight ahead. And you ask, who is more likely to know what's in the box? They're random. Okay? So there's a failure to connect at some level with what the eyes are revealing in terms of knowledge. And that seems to be true for many of the animals that have been tested.
I hate to do it, but we have to interrupt. We are finished with your time.
Okay.
Thanks a lot, Marc.
Welcome.
That was great.
Good.